Hey everybody, my name is John and I'm an engineer over at LinkPool. Today we're going to talk a little bit about what Chainlink Automation is and how to start implementing it into your smart contracts. We're going to start off at the automation.chain.link website. This will act as a dashboard for all of your new upcoming automation upkeeps. As you can see, I'm currently on the Arbitrum network, but we can change to many of the mainnet and testnet websites to play around on any network that you would like. Your active upkeeps, after you register them, will be sitting here, and then depending on the network, you can see some of the other recent upkeeps that other people have launched. To go into the docs, we'll be able to come in here and see some of the other supported networks. In our case today, we'll be launching on Sepolia, and you'll be able to see the addresses for registry and the registrar, but really the only thing you need to pay attention to is some of the registry addresses. You'll be able to see what the gas limits are as well, so when we start going into how to implement the contracts in your contract, you'll be able to just come back here and see what the perform and the check gas limits will be at. So let's start building a simple application. We're going to head over to our IDE. I'm using VS Code, but you can use whatever you're most comfortable with. I have a new project started already. I'm currently using Foundry, so I will link some docs on how to start with Foundry. It's very, very simple. And I'll start going through what the structure will look like after you init a new Foundry project. So we have our lib, which is basically where all of our other repositories or libraries that we include in our project will live. Right now, it's just the built-in Forge standard library that comes with Foundry. Your script directory will have your actual scripts to run, to deploy. Your source directory is where your contracts will live. They'll have when you init a new project, you'll have a new counter. You'll be able to see what it looks like, how you can test around with it before you launch any of your own. And of course, the testing libraries, again, counters for the counter contract that they have as a sample. For right now, we really don't need any of this, so we can delete this and eventually rename our project. So we need to do this for our code to compile as well, or it won't compile. So what we're going to build today is something called a circuit breaker. So a circuit breaker can be thought of as a way to either alert you or alert others that something has happened on chain. So we're going to build a very simple circuit breaker that will look for price fluctuations, and then the user of the contract can set a price high or low to either do something or get notified when a price of a certain asset goes above or below your preset ranking. So to begin with, we will call this the circuit breaker contract. We're going to come in here. We don't need any of this preset stuff because it doesn't mean anything to us. And we will rename this to our circuitbreaker.sol. Cool. Jumping into Foundry at a high level, you'll have your Foundry toml here. This is basically where all of your config will live. So in here, you'll see that the profile defaults are already set to source. So this is where all your contracts will live. You'll have an out after you compile to all your compiled contracts. And then your libraries or your modules that you bring into the project will live in lib. So there are a couple things that we need to do before we really set off. And depending on if you're using VS Code or some other IDE, you'll see already that we're having some issues importing certain libraries for the linter. And so we can fix this by number one, if you're using VS Code, bringing in a small directory and updating the settings. And so here we'll see some of the actual libraries that we'll be importing in case of OpenZeppelin for some of the contracts, and then also the Chainlink contracts. So in the Foundry TOML, we will end up bringing in something called a remapping. And so the remapping is basically pointing all of your contracts that you install to a certain area. So at Chainlink will equal the lib.chainlink after we start installing this, and same thing with OpenZeppelin. So we'll keep this here in the config, and that's really all we really need to do as of now, but we'll come back to the Foundry TOML a little bit later. One other file that we need to do is a makefile. So with Foundry, to run the commands, we'll use a makefile to run our more important commands. So we want to eventually include .envs. So to include environment variables in your makefile, we'll include that at the top. And we want to have an install command. So this install command will allow us to install the specific libraries or repositories that we wanted to import from. So we're going to forge install OpenZeppelin, and we can go per specific version, or we could just do it in general, whatever the newest version is. So for right now, we'll just go and add the contracts in general. And then we also want to do the smart contract kit and Chainlink. And so what this will do is download from OpenZeppelin, the OpenZeppelin repository for contracts, and then also go over to the smart contract kit and install Chainlinks as well. So a little bit different from, say, a hard hat repo or a Node.js repo is we will get something called Git modules from this. And so all your Git modules will be stored right here, basically kind of like a package.json that will show which, when you do install this for anybody else using this repo, you'll see which path and then also the branch version that we're using. So all of this will stay here. It will come in the lib, but this will not be imported or added when you push anything to GitHub. But you could do some more research on what Git modules are as well. Cool. So now that we have that, we can open up a terminal and run a make install. So it's already initialized in the Git repository. Good catch. So what's happening right now is with Git or Forge install, if you already have active changes, because the Forge init command when you start a new project will actually have a Git repository already set up for you. And so as you can see, we've already made changes to this. And so to before we install any new Git modules, we need to add these changes. So git add and then git commit, and then we could just do setup. Cool. So now we can go back and do another make install, and this should start installing. So what you'll see here is the Forge install is going to those repos and installing them, and we can see them being added in our library. So now we have a Forge standard output library, the OpenZeppelin contracts library, and then once this is installed, the Chainlink library. And you'll be able to go in here just like any other node modules would be. You can come in here, and then basically is a copy of their entire repo. So you can import and use those other contracts however you feel needed to. So once this finishes, cool. So now that's finished. Now we have the ability to import in our, and we can get rid of this now. As you can see, now we don't have any more linting errors, and we can go back into our circuit breaker and get started. And so with the circuit breaker, we want to do a couple different things off the bat. So we want to, number one, import a couple different contracts so we can start using them. The first contract is going to be the automation compatible contract. So I'm going to go automation compatible interface, and this is going to come, I'm just going to copy and paste the actual directory. Cool. So now the first thing that we've imported is the automation compatible interface, and then what this will do is it'll tell the contract that it is compatible with running upkeeps. And so when we create or register our upkeep, it'll see that this is a compatible contract to interact with. The second thing, because we're making a circuit breaker that's looking for on-chain pricing or pricing in general, we're going to interact with the aggregator price feeds. So we are also going to interact with the aggregator v3 interface. So checking to see that a price feed that we pass in is a traditional aggregator contract. So we need to import the aggregator v3 interface. So again, this needs to be switched. I'm just going to copy and paste to this. Cool. So now the linting is fixed. We know that the imports are working, so we can go now into our contract. So to begin off, we need to inherit from the automation compatible interface. So now we'll get the linting error saying that it doesn't know what this is, and it should be abstract because we haven't implemented the automation compatible functions yet. And so let's start off there before we do anything else, is adding what those things are. And if you're using any kind of GitHub Copilot, you're going to see a bunch of crazy stuff right here already. Don't worry about that yet. All we need to do is create two functions, which is the check upkeep. Check upkeep takes in a bytes and a call data, and this will actually finish a lot of this for us. So let's keep that and delete some of this stuff already here. Cool. So now we have a check upkeep function. It passes in some type of bytes. So this is what's passed in if we want to make a custom keeper with custom logic, which we will be. So we'll keep this in here. It's an external contract or external function, so it's only callable externally. It's a view, and it returns a Boolean if there is an upkeep that's needed, or if it's not, do nothing. And with the perform data, we'll see in a second, is this perform data will be then passed in to the next function that we add. So this will be perform upkeep. Perfect. It's going to autofill for us. This will take in this data that's passed back. So if this needs to happen, check upkeep is true. Automation does need to happen, then this will be passed to this as a callback. And then this perform upkeep will do whatever we need to do on chain. So let's start with, now that we have this set, you can see that the linting error has stopped, meaning that these are the two functions that had to be added to make it a compatible automation compatible interface. So now that we have that done, let's begin with creating a constructor. So the constructor will have nothing for right now, but we'll add that in. And then think about what we need to do for the constructor itself. So what do we need to pass in? I'm not going to be passing in any ownable contracts to have it that only an owner can use it. And so what we can do first is create a modifier that allows us, or allows just the owner, to use some of these admin functions that we're going to add. So let's add a modifier. This modifier, just like the ownable contracts in OpenZeppelin, will be called onlyOwner. Pass in no arguments. And it's going to require that the message that's sender should be the owner, and if not, it'll fall back. We haven't created an owner yet, so let's do that on the top. So we'll create an address, public, and owner. So we can see that the owner is whatever address that we will add into the constructor. And so we won't pass anything to the constructor, but the constructor will then, once deployed, the owner will be the message.sender. And now we can apply the modifier to any function that we want to make only admin. Cool. So now that we have this, we'll start thinking about what we want to do. And so what a circuit breaker does, or we want the circuit breaker to do, is basically be a limit order. So a limit order, a high or low. And so with that, we probably want to make some type of structure. And we'll call this structure a limit structure. So struct limit. And some of these limits will be, we want a low and a high. So a low number or a high number of what the price should be. So we'll have a uint256 of low and a uint256 of high. And we also want to have a, if a high or low is in effect. So this is incorrect as well. So we don't necessarily always want to have a high or a low, but sometimes we would maybe just want to have a low. So if it only reaches a low, do something, or if it only reaches a high, do something. And so with that, we're going to create two bools. So a bool low active and another bool high active. So what this will do is we can set this that in case we only want to have one of those active, we'll check if low or high is active before we do anything. And the last thing for our limit order is we want to have it that it's dynamic. And so not just so that we're checking for necessarily one pair or one price, we could possibly want to check for multiple prices. And so we can create multiple limit checks for individual addresses. So we want to have an address, which is basically just a feed address. And so this feed address is coming from Chainlink, and it's one of the Chainlink feeds. So in the case of what the ETH price is or what USDC price is, we can throw that address and create our own individual limits and store all those. So when we do our check upkeep, we can pass in, the check data can be the actual bytes of the address, and then decode that address to figure out which check upkeep are we performing on. Great. So now, let's minimize that a little bit. We'll have our limit structure, but we need to start creating our interactions with the aggregator itself. So come up here, grab the interface, and in the case of using individual interfaces, so say your contract only needed one individual interface, or one price feed, we could actually add the price feed up here. We're not going to do that for this because we're going to make it a little bit more dynamic and have the ability to have multiple price feeds. So for now, we won't be doing that, but we do want to add in a mapping. So this mapping, down here, this mapping will be a mapping of address to a limit object. And so what this does, it can be public for now, and we can name it limits. And so what the limits mapping is going to do is when we come into some of the future projects or future functions, the limits will be able to allow us to pass in a specific address to check what those limits are, if it be high, low, and if either of those are active. Cool. So now this is done, we'll be able to start thinking about how do we want to track all of this on chain. So the easiest thing to do to track anything on chain is listen to events. So we can create events to listen to, and then once those events are emitted, we can have something somewhere else to listen to these events to check if, say, a limit order has been hit. Or we could have some type of other contract function in here that we can talk about a little bit later at the end of this. But for now, let's create a couple of events that we can start emitting when any of this happens. So the first event will be limit reached. And what this event will do is take in a couple different fields. It will take in a uint 256 of low limit, uint 256 of high limit, and then an int 256 of current price. Great. So now we have the ability to emit one of these events and listen to it on chain when any of this happens. All right. So let's go back to our perform upkeep and check upkeep functions. So now that we're starting to get some of this done, we need to think about what will happen when we check an upkeep. So when we register upkeeps, the upkeep gets read every block, and we'll be able to check if an upkeep needs to happen. So here, the first thing that we'll probably want to do is we want to decode whatever this check data is to see which address that we're checking for. So in here, we will do address, because it is an address that we will be passing back. We'll call it feed, and this will be ABI decode the check data into an address. And if I can spell address correctly. Great. So now we have the information that's been passed through. It is the check data, which we want to decode into a feed because it will be an address. And then from there, we want to basically get the latest price. And so we should create a function that is going to be an internal function. And that will take in a couple different things. It will take in an address, and that actually should be all that we need for this. It will be an internal function, and a view returns a int 256. And I'll explain why we're using an int 256 in a little bit. So as you can see, Copilot's actually rendering what it thinks it should need, but we can take a look at the contracts and see exactly what we need in a second. So for now, let's see what it's saying. And it's basically using a aggregator v3 interface. We're passing in that feed. So whatever this feed address is turning it into an aggregator v3 interface. And then on that interface, we have to check the latest round data. And so that latest round data, as we can see, returns a round ID, an answer, a started at, updated at, and answered in round. And so all we really care about right now is the answer. And the answer gets passed back as an int, not a uint. And so we need to pass it and return a uint instead of an int, is why we're also emitting a integer, not a uint up here. And so we're going to pass in that feed from the check upkeep data. We're going to get the latest round data, that price, and then we're going to pass back that price in here. So now that we have that, we can go down here and we can get the latest price feed. So we're going to check the latest price, grab that information, and then we are going to create another function which basically checks if this price is in the bounds of the low high, or if it's not, then we can start emitting an event. So we'll create another function here, which is get limit. And that get limit can take in two things. It could take in the int 256, which is the price, and then it could also take in the address of feed. Internal, it's a view, and it will return a bool. So with this, we want to basically check a couple different things. We want to check if it is within the lie or the low and the high. If those low and highs are active, and if everything returns true, then we will return true if anything happens, or we will return false. So as you can see here, it is trying to autofill. So we will do if if the limits of the feed that we pass in, low active, and if this is true, and if the price is greater than the int of low, then we can return that. And so what we can do is copy one thing here, fix this quickly. Perfect. So now we'll have the limits of low active and then also high active, and return true if any of that is true, and if not, we will just return false. So now we have the ability to not just get the data on the feed that we want, but we can also check if it's in our limits that we're searching for, and if not, do nothing. So down here, we're going to upkeep needed. It's going to pass in the price and then the feed. Price is the get limit, and then the upkeep needed is basically a Boolean saying, is it needed? If not, don't do anything. If so, pass that back and then perform the upkeep. So in here, we'll do that, and then we'll also need to return the perform data, which is the API.encode. Actually, we don't need to do that. We just need to perform data equals check data. So instead of trying to API decode anything or encode anything, we could just say the perform data thing that we're returning is the check data that's been passed in. That should be exactly the same. Cool. So now that we have perform data, we need to understand what that perform data is going to do. So a good train of thought for anything with automation is recheck in your perform upkeep the same thing that your check upkeep is doing. So your check upkeep cannot change state in any way. It's really just a read function. And so it's just checking to make sure that something needs to happen. And then you want to recheck that again, just to double check that it is true. And so what we'll do is we'll run the same data again within the perform upkeep, and then physically change state that needs to be changed from there. And so for this, we can do the same thing. So add all of this, add this. And what we could also do to make this even easier is we could just run check upkeep with the perform data. So instead of duplicating any amounts of code, we can, actually that won't be able to do that because it's a external function. So all right. So this does not need to be here. This is where Copilot kind of goes out of control. That does not need to be there. What we're really just doing is checking the latest price and making sure that's the same thing again. And then we're going to check if we need an upkeep again. And if needed, so if upkeep needed, we can emit the we need to have this as a bool. So upkeep needed is the Boolean that we get back from getLimit. So if this is true, we will emit a limit reached event. And what this limit reached event will show is that whatever the limits that we have preset and whatever that is currently set is higher or lower than the price. And so with this, we can read off chain and then do something or get alerted because of this. If nothing needs to be done, then nothing will need to be sent back and your upkeep doesn't do anything. So now, once we have all of this, this should be now working, and we can now have some setters and getters for any information that we want to add in here, because right now there's nowhere to add any actual limits. So we want to set a limit now. So the best thing that we can do for that is create another function, and that will be set a limit. And that limit will pass in a high and low, so a uint256, a new low limit, and a uint256 new high limit, and the address of the feed that we want to look for. Cool. So because we only want this to be run from ourselves, we are also going to add the only owner modifier so that nobody else can run this other than whoever's deployed it. And then in here, we are going to check for a couple things. So we're going to require that the feed number 1 is not a 0 address. So it's not a 0 address, and you can see it's going to autofill for us. Feed address cannot be 0. I don't really like 0, but I'll do 0x. So it can't be nothing. And then we're going to do another require statement. And what this will do is check the new low limit is greater than 0, or new high limit is also greater than 0. Yeah, so one of these has to be set. So this will require one of them to be set. You don't have to set any or both of them. Once we have that, we could set the bool of low active equals new low limit. And bool high active, again, we'll autofill that, equals the new high active. And here is where we will create our new limit and add it to the limits mapping. So limits of the feed equals, back here, equals a new limit. And that new limit will contain the new low limit. We can really just autofill all of that. So the new low limit, the new high limit, low active, high active, and then the feed itself. So this will act as a new limit and add it to the mapping. And we can think about how we can add a new, so a new event and emit that new event. So how about we do that up here, and when this happens, we will emit an event saying that a new limit has been set. We'll add a uint 256 for the low and high. Actually, let's call this limit updated. And this will be a uint 256 of low limit, uint 256 of high limit, a bool of low active, that, a low active, another bool of high active, and then the feed itself. Cool. And this is not in parentheses, so there we go. Okay, so now we have this other event. We can go back down here, and when we create this, we can emit this event, adding in the new low limit, the new high limit, and if either of those are active, and then also the feed itself. Awesome. So we are almost done with this contract. The one last thing that we can look at is sometimes adding in just an event emitted really doesn't necessarily do anything other than alert you. So what if we wanted to have it change some other contract? So if a price goes up or down, we can have that change or activate a function on another contract to do something. And so let's add in some functionality that will allow us to not just emit events, but also allow us to add contract functions to also do something else. So let's create another structure. So struct, and we'll call this external contract. That external contract will have an address, contract address. We'll have a bytes, and this will be a function selector. And we'll also have a bool of status to say, maybe we don't want to run this all the time. Maybe we just want to run it on certain times. So now that we have this set, we can come down here, create a new function called update the custom function. So a custom function is really anything that we want. So we can create a function here that's set custom function. This will pass in some type of address, which is the external function contract address. And we'll do the bytes, and this can be call data of a function selector hex. This will be an external call, and we'll say only the owner can call this. So now we are going to, number one, require that this external function is not a 0 address. Make sure that's true. And then also require that the function selector.hex, the length is greater than 0, so that something has physically been passed in there for that. So now, once that's happened, we can create a new variable up here, which is just do it above here. And this can be called a external contract. So take this and external contract. So now we have an object up here that's an external contract, and we can create it and reference it from here. So this will be external contract, and it will autofill for us. External contract is an external contract which passes in a new address, a function selector which we pass in from whatever that function is that we're calling, and if it's live or not. So right now we're going to say, yep, that's true, that's live. Now that we have that, we can create a other function which actually does something with that. So we'll call this a function and then call it custom function. And so the custom function is going to be, we'll say public actually. And the reason why we're going to say call it public is we want to run this not only in the contract. So if perform upkeep is called, we can run it within the contract if it's public. We can't do that if it's external. And we can also call it, just in case we want to call it, if we are the owner of the contract as well. And so we'll create a new modifier. So in here, we will create a modifier called only contract. Only contract. And it really isn't just only the contract, it could be the admin as well, but to make it easier, we'll do this. And we want to see that the contract is the sender, or so the message.sender is equal to the address of this, so basically this address, or the message.sender equals the owner. So this will pass if the message.sender is this address itself, or if it's the owner, which we've set up here. And we can go back down here and say only contract as the modifier. We don't need to set all this yet, but the custom function basically is going to take in a bool. So bool OK equals external contract dot contract address dot call. And so what this is doing is the external contract and the contract address is the contract address that we passed in, and the so contract address is the contract that we pulled in. So this contract address itself is going to call the external contract.function selector. And the reason why it's getting an error is because we need to pass in another parameter or another return, and we're not going to use that return. So we're just going to use the if it worked or not, and we are going to require that it is okay, and if not, then the external contract function call failed. So now that we have this custom function ready to go, we can implement this custom function in here. And so we can do another if that status. So if it's true, here and here. So if the custom function returns with a Boolean, or if the status is selected as true and it's live, we'll run this. If not, it won't do anything, and then the custom function logic will run. Awesome. So now that we have everything set up, we'll be able to physically launch not just the contract, but also go in and look through the different price feeds to see which price feed that we want to start looking for. So in the case of USDC, if we want to check if it's depegging, or if we want to look at ETH and check if it's high or low, or any other price feed that is currently on Chainlink, we can pass that in here and do some kind of third-party logic, or just look at events through here. So now that it's set up, I hope this gives you a little bit of an idea of how we can do dynamic price data. we'll go in on the next video on how we can actually perform this data through the automation.link homepage, and how you could start passing in and creating your own custom functions from there. I hope you guys learned a lot. If you have any questions, feel free to leave them down in the comment section, and I'll see you guys next time.